Okay, we have an example file here and wanted to show quite a difference of how to create a parametric constraints versus using some of our intelligent attachment points to do the same thing, and how the differences in timing and speed are captured doing this. So for example, we have these two parts. This is our base part that we're using here, and we want to put this orange part along this edge, along this other edge on the opposite side, and then one in between. So typically you would have to create the parameters to drive these if for example, if the model changes, so you can get the size information. So what I'm going to do, just in this example, I'm just going to create a parameter here on the IntelliShape level, and that's going to be our length parameter for this block. So we'll say BL for that, and that's 80, and that's just going to be a reference because we're just going to pull that value because this is going to be our driver for our model. So that's our reference from that direction, and we'll go over here to our width direction and create the same thing. In this case, it's going to be our block width, and again, it's going to be a reference parameter. So that's just getting that information, and we want to use that to drive our other part. So we can do some other things here. We can go to our parameters table, and we can see for our part selected, we have our two there. We can add part level parameters. We'll call this part 1, 1 length inside of here, and I'll create another parameter, part width 1, or part 1 width, sorry, part 1 width, and we'll just leave it 0. And what we'll do is just type in these values to drive that. So that'll be the BL for that one, and this is going to be our BW for that one. So you'll see that it'll actually pull that value as an expression to drive these. So these are what I'll use to drive our other part. So we can do the same thing for our other part. In this case, we only have one driver here, and this is actually, I'll go ahead and move this out of the way. This is our length of this thing. This is the thing that adjusts. Everything else is just going to be fixed in this case. So we'll make it simple. We'll create a parameter on that one. In this case, instead of being a reference, it's going to be a driver. So this is going to be our we'll call it a different one. We'll call it block 2 length. Okay, so we'll call that our block 2 length, and this is going to be driving because we're going to drive that. Again, we want to use the part level to do this so they're at the same level. So we can go back to our parameters. Again, there's our part 1 there. We'll add this one here. This is our part 2 length inside of there, and we'll just set a value for this for, let's just say 30 for now. And what we want to do in this case is the opposite. We're going to drive the B2L by P2L. Okay, so that will get us started here in this case. So now we've got our parameter set up that we can drive the lengths. You saw that adjust there. Now we need to position this. So this is where the differences kind of come in on the parametrics versus the attachment points. So I'll go through this, and we'll go through and show you the difference with the attachment points. So to get this located over here, and we know it's got to change size, we need to position it somewhere so that it can update. So one way to do that is to go to the assembly ribbon up here at the top. We got our position constraints. In our case, we're just going to pick this point and move it down to this point here. So that'll put us on the top with a coincident constraint inside of there, and it'll lock us down, and we'll go ahead and hit OK to place that. Okay, so now we need to do the same thing. We need to make a copy of this to the other side. So what we'll do is we'll just turn our tribal on, make a copy. We'll just link it here. We can make a link or a copy, doesn't really matter. In this case, it's going to be symmetrical, so we can probably make it a link, and it'll control the same thing. And now we need to also have ones on the opposite side, so we can rotate this around, or we can drag and drop it into the catalog. Either way, we'll just turn on our tribal here, and we're just going to take this and rotate it 90 degrees, but we're going to make a copy of this because it's going to be a little bit different. So we're going to take 1 and 290 on there and hit OK. Now we have a copy of that, and while we're here, we'll just, oops, I forgot to switch over to the other shape. Click that guy there, and we'll make a copy. Actually, I'll link that guy there. Okay, so now we've got all of our pieces that need to be on these corners, and we need to basically do that same thing. So on this part here, we'll go and do that same position constraint. We'll move that to that corner, and if you hit the left key, that'll actually apply that, and we can kind of repeat this around. So in this case, we need to move this one to this location here, hit the key to lock that in place. And now our issue is, how do we get the other one in place? Okay, since we don't have a location here for this yet, we can go ahead and do the parameters, then we'll do it. So let's just go ahead and make it easy. We'll go ahead and put those parameters there, and then we'll lock it down. Or if you want, you'll see it actually change. We'll just put it here on this point there to there, and hit OK and apply. So now we've got all these kind of positioned on this face for the change, but we need to do the parameter. So now we'll go into our parameter table, and then we'll have to look and see what we got here. So we have a bunch of things that are copies inside of here. Since we have duplicates, I'm showing all of them. So we can see that there's these added these PL1s, or sorry, P2Ls underscore 1 underscore 2, because it's creating duplicates of these parts, which is fine. We can rename those to make it clear, but we can just select on these to see what we've got. So we've got this particular part, which is showing this one, and we got this one over here is showing that. So this one is the one we want to drive first, which is going to be the same as our part 1 length. So we're going to go ahead and type that PL1 there to drive that. Oops. Oh, sorry, P1L inside of there to drive that, and you hit apply, and you can see this adjusts to that length. This one is linked to it, so it adjusts as well. Now we just need to do the other one, which is actually going to be our width of our part. So it's going to be this element here, the P1W, which is going to go into this part. So we're going to go, this one's going to be P1W inside of there. However, we've got, these actually are 7 centimeters here, so we need to subtract this distance here, because it's going to go all the way. If I type it in there, it'll actually overhang. So you'll see this, if I hit apply, it'll actually overhang that geometry. So we need to subtract some information here so that we just know this. Those are 7 centimeters, so we'll just times it times 2, or just type in 14 centimeters inside of there in this case, and now we've got those aligned. So now we hit OK. We essentially got this thing set up parametrically, and we can now go to our block and adjust this, and we can see that will update that direction, and this will update this direction. Okay. Fairly straightforward, fairly simple to do with parameters. And this is a simple example, but just kind of give you an idea. And this, this part is coincident and only one constraint that we needed. You could have done mates, then aligns on these edges, things like that. But you could do it with a coincident in case, coincident constraint in this case to make it simple. Okay, so that's one way to do it with the parameters. So I want to show you another case how you can do it with attachment points, which actually enables you to reuse this design. So say you're going to create this often, and you may want to drag and drop out this plate and have these things adjust in size, and you may have other parameters on here as well. I'm just going to show you a different way, because if you imagine if you have other things that's changed in this, like the thickness, you have to change that parameter in there. To do that, it gets a little bit complex, and you had to make links of these things to do that. So let me go ahead and back up a little bit. So we'll go ahead and delete these parts here, and I'm going to keep this part. I'm just going to delete this constraint, and we've got I'm just going to move this out of the way so we can kind of get an idea of what we got. So I'm going to move it up here inside of here, and we've got parameters on this. So if we go to parameters again, I still have that parameter there, so I want to go ahead and show all the parameters, and I'm going to delete that one that I just created here for these guys. So I'm just going to go ahead and delete that expression. It's probably this one here. Hit OK. So now if I change this guy, nothing's changing. So we got that those set up differently. So what we're going to do is show you how to do this with attachment points, which is a very unique thing. So they still have the parameters on here. We still have this guy set up that's pulling the length and the width, and we've got this guy that's still set up to pull or drive the length of this particular element. So we've got those set up. So what we're going to use, if we go to our tools catalog, we have attachment points here. What we're going to do is we're going to go on our base part, and we're going to add an attachment point onto this face. It doesn't really matter for now. I'm just going to put one here so I can see what it is. And what I'm going to do is I'm going to go ahead and set the name and behaviors. If I right click on it and say set name behaviors, I can drive this thing. So I'm going to just give it a name. It doesn't really matter the name. You can use anything that helps you identify it. And we're just going to use a neutral connection. Now what we want to do is we can actually use some additional capabilities or intelligence to drive anything that drops onto this part. For example, we want to say when a part drops onto this, you want to set its particular variable. So we know this is orange part is P2L, and we want it to use one of these two variables here. So we want to use the length or the width inside of here. So in one case, we want to have a P1L, which is this length value when it drops here, and we'll change it to something else on the other one. And then you can do things like add it as an expression. What that does is actually creates that expression for you, so if this changes, that will change as well. So we'll say, yeah, go ahead and do that, and we'll add that. So that's going to create our first attachment point, and we can actually have it create in a constraint as well. So we can create constraints for the coincident constraint on that attachment point, or things that can move along the parallel or coaxial, things like that. So anyways, we've got that created, and we're going to go ahead and hit OK. So now that we got this attachment point, what I need to do is place it in locations. Okay, so the easiest way to do that is actually just to right click on that attachment point and drag and drop it into a catalog, and then I can drag and drop it out onto this part level. Okay, so in this case I'm going to drop it down here on this edge, and I'm going to drop it on the center point because I want it to always maintain the center location on this part. So I'm going to just drop it onto there, and notice you have to keep an idea of what your X, this is our X's are red and our blue is our Z, what direction those are, because those will make a difference when we connect these. So I'm just going to drag and drop these on all edges, and then notice the X is always pointing on the inside when I drop on this edge because it's my viewing direction, and the Z is along the edge. Okay, so those are okay. Now we don't need this one anymore. All right, so we got this. So remember, we put this constraint that it's going to say it's going to drop on the P2L, and it's going to set it to that length, which is great. But on this side, we can't use that length because it's actually the width on these. So if we want to go to these, we can edit those by right-clicking on it. We're going to actually change that variable. So we're still going to set the length of this particular part, but we're going to actually use a different variable. So that's actually going to be our width value. And again, we need to subtract the 14 centimeters. And we're going to go ahead and modify that expression. So we've got that set up. Hit OK. We can drag and drop that one into the catalog and drop it on the other edge to save us the editing time here if we want. So we just delete that attachment point and drop that second one back there. So now we've got that one and that one set up the same. Or we could have linked it over there, either way. Now we just need to create one on our part. So now we'll go ahead and create an attachment point on our part, and I'm just going to create it on the center again on this bottom edge of this part. And it's got our Z in one direction. Now this is where you need to keep an eye on your attachment point location. So what we do when we drop, we align the Z's, and we anti-align the Z's and align the X's. So the X's are in the right location, but if we do use this Z, it's on the bottom edge, it's going to flip this thing to the opposite side, so it's going to be upside down. So I can just go into this part here, grab that attachment point, and I'm just going to simply rotate it 180 degrees. Okay. Now I've got it set, and now I just need to give it a name again. Remember, what we used the first time was that connect. So all we need for this guy is that name connect inside of here. I don't need to set any expressions because it's going to pull from these. Okay, so go ahead and hit OK to this dialog. So we just got our connect neutral into that part, and now we can have this in our catalog. So basically, you could have multiple ones, different sizes, different variables, different shapes, colors, whatever, different holes and patterns on these, and just put these in the catalog. Just one attachment point is all you need. And then we can just delete this because we don't need that there. So what's going to happen is when I drag and drop this out, it's going to apply, it's going to snap itself to that location, it's going to apply the length of that automatically for us. So I can drag and drop this onto the other side. You notice it does the same thing. I can drag and drop it here. You notice it took the 14 off, snapped it to the center, and automatically applied that. So it built all that intelligence as we were dropping. It still has the same behavior. If I adjust this, notice everything will update because it built it as an expression to do that, so we can do it either way. So just wanted to give everyone an idea that you can actually use these parameters to drive your geometry, which is your typical way that you find in most CAD systems. They have your mate and lines and your parametrics to do that, to drive your geometry. But just wanted to give you another idea of how to use this, as we've shown in other videos about our intelligence, using smart assemblies attachment points to build this. And you can have all your parts have that same connector and have different options, so it can drop on here, change different things at the same time, because you can have multiples on those attachment points. So if we look at our part, for example, this attachment point, if we click on that here, if you can Control Alt and click on that, you can get that attachment point. We can click on that and say set name. You can add as many variables as you want. So I can not only just drive that one part that's dropping on there, I can have a different variable for a different part, and it'll apply whatever it can find when it does that. So it's a very handy tool that you can build up very long connection strings inside of here with all kinds of information for different parts that are dropping on that, so they could have different behaviors, which is really cool versus doing the mate and lines for various things over and over and over and over again. So it can save you a lot of time if you're having multiple or configurable type parts. Hope everyone enjoys this and can make use of this in some of their design process.